Hi there. Welcome to Integrating On-Prem Resources in Your Zero Trust Journey. My name is Alex Sesabov. I'm a program manager on the Microsoft Cloud App Security team, and I'm joined by my colleague, Jasmine.
Hi, and I'm Jasmine Bethhauser. I'm a senior program manager at Microsoft, and I work on the Azure Active Directory team. I focus on helping you connect all of your applications to Azure AD, including those hosted on premises, so you can easily provide remote access to these with app-Proxy.
Thanks, Jasmine. As I mentioned, we're going to focus today's discussion on secure access to your on-prem resources. But whenever we talk about secure access, we must root that discussion in zero trust and its principles. With so many different access points across devices and different users and their groups, and the actual data inside of the application that they're accessing over different networks, the historical perimeter-based security model that we have in our heads, it just doesn't keep up and it doesn't scale with the sophistication of today's threats. So regardless of where every single request originates from or which resource it accesses, zero trust teaches us always verify, don't ever trust. And in this zero trust model, before granting access, we perform strong authentication, authorized within policy constraints that we'll show you, and expected for anomalies. This system is checking everything from the user's identity to the app hosting environment in order to prevent that breach that we all stay up at night worrying about. Another important principle of zero trust is least privileged access, meaning that we only grant access to the people when they need it and for the amount of time that they need it and for the specific task at hand. Least privileged access means that we're granting just in time and just enough access. Risk-based adaptive policies used to protect both data and productivity. And finally, zero trust also means that you should expect breaches to occur. An always vigilant mindset helps you to be proactive so you can minimize and prevent lateral movement inside of your organization. You should always use techniques like microsegmentation that we'll talk about today, strong encryption, telemetry, in order to spot these breaches faster. And doing so means that it will soften the impact greatly when these breaches do occur. Here is a slide that helps to visualize exactly what we're talking about when we talk about zero trust. And one of the things that I want to draw your attention to is that we are going to show you throughout this presentation how everything is unified under one plane. We see users here, we see devices, networks, all of these various conditions that can feed into the risk of a session. Then we see this access policy that says, do I give the user access? Do I require multi-factor auth? Do I apply granular session controls on top of what they're able to do? And it's all unified across your resources, whether those are SaaS, IaaS, or PaaS, whether they live on-prem or in the cloud, whether the cloud is Azure or it happens to be AWS, GCP, or yet another cloud. The common theme here is that throughout this presentation, you'll see that the concepts that we talk about in the context of on-prem access actually span across any of those resources that you're interested in, across any of the various conditions that you might want to incur those policies in as well. Everything that we talk about today is especially relevant as we all go through this transformation that none of us expected to occur quite as quickly as it's happening. More likely than not, suddenly you and your workforce, or at least a big chunk of it, have been forced into remote access. This means that there's an explosion of unmanaged devices. Users are scrambling to use their phones or their own personal laptops or whatever they can to connect to their various resources and corporate applications around the clock. This overnight extended the bounds of your network to basically include the entire internet and all of the various risks that occur out there. And it also means that we're now faced with shifting from network segmentation, that corporate versus non-corporate view, to app segmentation. We are slowly learning, and in some cases being quickly pushed to learn, that every single application carries various types of risk, has various types of data in it, and every single app across every single session that a user connects to that application from needs to be segmented and individually treated with its own characterized risk.
As Alex mentioned, many organizations still use more traditional approaches like using a VPN or DMZ-based reverse proxies to provide access to critical on-premises resources. These solutions made a lot of sense for when the digital landscape was much simpler and everything including apps, and the users connecting to these apps could be confined to the walls of their own corporate network. As organizations quickly scaled to support remote work, and end users continue to expect instant access to any app from anywhere, and often from unmanaged devices, these solutions made it much more challenging to scale. In fact, from the end user and admin perspective, they often don't satisfy most of the essentials, like having a simple, consistent, and fast experience, while also having in place security controls that can reduce the attack surface and verify explicitly. And lastly, also allowing the organization to reduce the cost of maintenance by moving to a more cloud-driven approach. So the right solution is one that employs the principles of zero trust and can also leverage global scale to provide great service and performance. It allows you to only give users access to specific applications they need rather than broad access to the network. And because it's tied to their identity, you can also automate and govern access so that when employees join the organization, they're granted access to the right applications based on the groups they're in, but access is also removed when they no longer need it. With Azure Active Directory, we make it really easy to connect all your applications to have a single identity-based control plane to manage everything under. When it comes to cloud apps, we have support for standard authentication modes like SAML, OIDC, and for your new apps your organization is developing, we have tools and SDKs to help you integrate these as well. Now for on-prem apps, we have a couple different options to help you connect these apps. First, you can replace legacy authentication apps with new SaaS apps. For example, your on-prem SAP application can be replaced with its SaaS equivalent app. Second, you can invest in code changes to modernize your auth. Maybe this is to SAML or OIDC. And then third, you can use Azure AD App Proxy or one of our partner integrations with network appliance providers to authenticate with Azure AD with no changes required to your on-prem app. And today we want to focus on showing you how you can easily apply the same policies and security controls you use for your cloud apps to your on-premises apps using Application Proxy. Usually, you have the typical scenario where you have a particular app hosted on-premises, like in this example, our TFS application, that your users regularly access via the network. And now you want to provide remote access to this app so that they can access the application when they're not connected to the network. Now, to set up Application Proxy, the only requirement is installing a lightweight agent called a connector on a Windows server on premises. This connector service allows us to have a connection point to your on-prem network, and it can be used with several applications. So one connector group can serve all of your backend applications. It also uses outbound connections, so no additional inbound firewall rules are needed to be opened up, and it does not require being placed in a DMZ. Your apps also do not need to change. You can maintain these as is, and App Proxy can support multiple types of authentication modes, so users can still get a single sign-on experience. In this example, you can see how this app uses Windows integrated authentication, and the connector can do Kerberos constrained delegation to sign into the app on behalf of the user. So from the user experience, they're just using their Azure AD credentials to sign in once and get access to the app. Users can then access the app from the external URL from any device, no VPN required. So long gone are the days of having to try to disconnect and reconnect to VPN to sign in successfully. When a user does access it, we also ensure that Azure AD pre-authentication takes place so that every request is sent to Azure AD services to make sure that they are verified and authenticated first. That way, only the verified traffic ever gets to your app, thus giving you a layer of authentication that protects your app. And in addition to that, any conditional access policies that are also set are enforced at that point. And then from there, the connector can pick up the request and return the response to the user, and they now have access to the app. So now I'll hand it back to Alex to talk a little bit more about what's happening during that conditional access enforcement.
Once the app is deployed, a process that Jasmine showed was incredibly simple. It's brought under the same management plane as any cloud app that you've configured to work with your identity provider. That means we can now apply the same basic and advanced conditional access policies to gate access and control your data, depending on all those conditions we previously talked about when we touched on the principles of zero trust. Here we can see some of those conditions on the left, and we can see how diverse they are, depending on which authentication method or device or location, whether it was corporate or non-corporate, which type of application you're accessing, or whether it's a control that accompanies that condition. Like, do I want to allow access or block access? Do I want to require a password reset? Do I want to block legacy auth? Or do I want to limit access and require multi-factor authentication, perhaps, across any of those resources? And we've highlighted here specifically require multi-factor authentication and limited access because those are the demos that we'll walk you through today as just a couple examples of the powerful capabilities you can add to your on-prem applications. This is a visualization of one of the type of sessions that a user could access a resource from. In this use case, we're going to require multi-factor authentication when a user comes from an external IP address, a non-corporate IP address, if you will. So we can see on the left here some properties of the user. We can see that their role is marketing manager. They're last signed on 3 hours ago. And the only slightly risky thing here is that they're coming from a non-corp network. Now, we just talked about remote access. We talked about how many different employees, colleagues are in the exact same boat today. So while it's a non-corporate network, we of course still want to allow access. We just might want to check that the user is who they say they are. Their device is perfectly healthy, it's patched, and we've seen them from a non-anomalistic location previously. So we say, okay, this session has some risk, but not a whole lot. We're going to route them through TFS. Or route them to their application TFS, but along the way, we're going to require multi-factor authentication in that Azure AD conditional access box. On this slide, we'll show a slightly riskier example. The same user in the previous example is again spinning up a new session with their TFS instance. They're actually coming from a corporate network this time, but in this case, much like the other symptoms of this remote access work, they're using their own personal device, and it's unmanaged. It's not managed by the organization. We don't know what kind of malware might be on that device, and so of course there's more session risk about files falling into the wrong hands or data being exfiltrated outside of the organization. So in this case, multi-factor authentication is great, but we actually want to apply additional controls. After going through conditional access is going to send this session to Cloud App Security, and we're going to proxy every single request between the user and the application. We will let them view all of the various files so that they can continue to be productive, continue to make code changes in the browser, for example. But when they try to download a file onto this unmanaged device, then we'll block that download. And now that we walked you through these two examples on paper, I'm going to hand it over to Jasmine. She's going to show you how to actually onboard these various on-prem applications in Azure AD. And then we will show these same examples, these use cases we walk through on these slides, come to life.
To start off, I'm here in the Azure AD portal, and I'll first go to Application Proxy to make sure that the connector I installed is up and running. Here I can see that I have exactly one installed for my scenario, which is getting our team's on-prem TFS application secured and accessible for remote work. We recommend installing at least 2 connectors in a group so that you always have high availability for your deployment. So since this is set up, I can then go ahead and integrate my application. I'll first go into Enterprise Applications, and then I'll select Add a New Application. From here, I have a couple options that I can integrate my apps with, whether it's a pre-integrated app or one that's attached to a cloud platform. But in my case, I'll be adding an on-prem app with Application Proxy. From here, there's only a few fields that I need to fill out to enable remote access to my application. This includes adding in a name for my app and as well as an internal URL, which is the URL typically used to access the app locally. And that then maps to an external URL that I can get to this application from the internet. I have a few options for the external URL, I can either use the free MS proxy domain provided or customize this so that my users don't even have to remember a new URL if they're outside work. I also will make sure that pre-authentication is set with Azure AD. That way, any request trying to access this app will have to be authenticated first before reaching the application. Now that my app is set up, I can also go ahead and configure single sign-on for my application. In this case, TFS uses Windows Integrated Authentication. So all I need to do is configure the SPN required for that app, and my connectors can now sign in on behalf of my users. I can also choose different types of sign-in modes depending on what type of app I have. For example, we also natively support SAML, password-based single sign-on, and as well as header-based single sign-on. The last thing I'll do is add a conditional access policy for my application. The first conditional access policy I want to set up is one that requires all my users to use multi-factor authentication when they're trying to access the TFS application from a non-corporate location. So here I have all users set up for this policy, and I've also added the TFS on-prem app that we set up to use this conditional access policy. As for my conditions, I have in the locations section that I've excluded all trusted locations. So that means anytime my users are coming from the IP ranges that are trusted, such as those on the corporate network, they don't have to deal with the MFA prompt. But as soon as they're outside that or accessing it remotely, that's when this policy will kick in and enforce MFA. And then lastly, here you can see that we have require MFA as the policy being enforced. All right, so after I've set that on, I'll go ahead and switch that for this application. Now, the second policy I want to set up for this application is a little more fine-grained. Here, I want to also block downloads in TFS if it's coming from an unmanaged device. That way, whenever a user is perhaps using their own device to access some of our sensitive data in the TFS application or sensitive projects, we can enforce that they're not able to then download it on that device. So similarly to my first policy that I set up, I have this enforced for all users, same application that we're adding this on to, and then I have two specific conditions selected. So here in device state, you'll see that I'm excluding those that are Azure AD joined or marked as compliant from it. And then as terms of the session controls that'll take place, you'll see here we're going to be using conditional access app control, which is where this is deeply integrated with Microsoft Cloud App Security to then block any downloads if they are coming from an unmanaged device. Blocking downloads is one example of a pre-canned template I can use. There's also one that allows me to just monitor only, and then you can also create your own custom policy. All right, so from there, once I have that set up, I can go ahead and also enable this policy. And now my application will both enforce MFA when that user is coming from a non-trusted location, and then as well as if they're on an unmanaged device, we can then even block downloads and have that in-app real-time security control. All right, so we just completed configuring our TFS application so that our users can access this remotely via application proxy. We've also enabled single sign-on so that our users can get a seamless experience into that application without having to deal with multiple login prompts. And then we've also enforced our security controls on this app using our conditional access policies. So now I'll pass it back to Alex to show us what it looks like from the end user experience.
So Jasmine just showed you the experience for onboarding an on-prem application with Azure AD, and then configuring two different types of conditional access policies to apply. One was to require multi-factor authentication from non-corporate IP addresses, and the second one was to create a sort of read-only mode when coming from an unmanaged device. So in this case, allow users to make code changes, but block their ability to download files onto that risky and unmanaged device. I'll show you the end user experience just for that second scenario in the interest of time. We can always show you how to configure the multi-factor authentication option as well. So here, I'm an end user. My name is Kevin, and I've got my TFS on-prem instance here that I'm launching from my app portal. And I click on the instance, and almost immediately you see that I'm redirected to Cloud App Security, actually. And I'm told that, hey, my access is being monitored. This screen is, of course, configurable. It can be shown or hidden. In our case, we've decided to show it maybe for compliance reasons as an administrator. But as the end user, I'm going to click continue to the actual on-prem application. And you can see how quickly the on-prem application boots up, even though it's actually going through our proxy. So the application will look exactly the same to the end user, but we'll be able to control various types of granular actions. So in this case, I want to go work on some code. I will open up this example project, and I will click on the code. I will go to the source file, and I have this example.java file. I'm going to go in and maybe edit it. You can see how responsive this is. Maybe add a second class, example2. It's going to stay empty, and that's it. I'm done. So, of course, I can make changes like this. I can continue to be productive. I'm going to discard this particular change. But if I try to download a file, you'll notice that when I try to download that same file, I actually get this download blocked. You cannot download company data onto personal devices. Contact our administrator for more information. And this file that downloaded here is a simple text file that replaced the original file that was attempted to be downloaded. And it just tells you the same thing. It cannot be downloaded because of sensitive data. And you can contact the administrator for more information. So we showed you a couple demos. We brought to life how to onboard the application, what the end user experience is like. We want to spend a couple minutes talking about new features in this space that apply to conditional access policies, granular session controls, and your on-prem applications. One of the new things that we're super excited to announce is the ability to also block uploads and downloads of malware. So in addition to being able to block uploads, downloads, cut, copy, paste, print, and various activities like this based on the sensitivity of your data, we are now actually able to scan the file and compare it against a database of known malicious hashes and decide what can and can't be uploaded or downloaded based on that. So this is a super powerful feature that can be applied to any web application now in real time, as long as it's managed with Azure AD, regardless of whether it's on-prem or in the cloud. As long as it's got that federation with your Azure AD as your identity provider, then we've got this capability built in for you. The other piece of this is in conditional access. There's a new condition that we're all super excited about. You know about the power of Microsoft Threat Intelligence, and you know that we can use it to identify user risk based on a whole bunch of different parameters of what the user has done in the past, what kind of risk has built up over time. So now all of the various policies we've shown you here and much, much more can be applied not based on who the user is, for example, but based on whether their risk is high or medium or low. So you can gate access and gate these granular controls based on that information.
We're also happy to announce we recently released support for using application Proxy with Remote Desktop Services web client. This is helpful if you're hosting apps on remote desktop services and you want to protect the connection to the web client with Azure AD authentication and your CA policies via application Proxy. For our last announcement, we're really excited to share that very soon we'll be releasing the ability to integrate header-based authentication apps natively with application Proxy. So you can use your existing deployment and set this up with no additional components required. Here you can see a quick glance of what the experience looks like when you're setting up the headers for your application. As you can see here, you can configure whatever set of attributes or transformations that you need to use on those attributes. And then those headers will be translated and mapped to your configuration and sent down to the applications when your users are accessing the app. So stay tuned for that public preview release.
So to conclude, we wanted to leave you with some go-dos and some resources that might be helpful to you. Of course, tomorrow, in 1 month, in 6 months, there's no one size fits all. So take these for what they are and, of course, apply them as they apply to your specific organization. And we're happy to help guide you through this process. But in the short term, what you want to do is discover all the various applications being used by your users, shadow IT, if you will. And among those apps that you didn't know about, you'll want to manage some more closely with your identity provider. And so you'll want to connect or create a plan to connect those applications to Azure AD. Once they're connected, we're now able to migrate these various applications that might be on-prem to the cloud. We might be able to more tightly manage those applications. We'll want to enable conditional access policies like the ones that you saw today for both your on-prem and your cloud apps. Whether it's MFA or blocking download or yet another policy, you'll have that one central pane to do that for all of your various resources. And of course, once this becomes a habit, we want to migrate at scale. All of the various apps that your users are using that you want to centrally manage access to, move all of those to Azure AD as your identity provider and create this one central pillar with identity at the center of it to manage all of those applications more tightly. And a couple of resources. We talked extensively about application proxy and cloud app security. These really behave as one product. But if you're interested in the how to onboard applications that are on-prem more closely, like Jasmine showed you today, go to that first link. If you're interested in looking at the various types of granular security policies you can apply, go to that second link. We're here to help you on this journey as you adopt these zero trust principles to both your on-prem and your cloud resources. Thank you very much.